in number of forces such as P1, P2, uh, P sub n. No? So meaning there are subjective of this body here. Nakita niyo class ang aking gipaste?
Yes, sir.
Okay, so we have here a body, no, color blue. Now subjected to forces, no, arbitrary forces, P1, P2, Pn. Okay, so we are going to consider the external work here. The external work done by these forces is equal to the internal strain energy stored in the body. So, as long as dunay external work nga gi-do sa iya, there's also an internal strain energy stored in the body. No? So there is transmission from external work to internal strain. So just like our human body, if we do extraneous work, we will have some internal strain energy that is stored in our body. No? Now, by conservation of energy, no, it says here that the external work done is equal to the internal work done. Okay. So, however, external work is a function of the external load. So, based on the simple equation, U subscript E is equal to U subscript I. So, the first equation, U sub A, is already defined. So, because this is what we call the external work, and this is a function of external load, such as the P1, P2, P3, so like that, no? So in simple equation, it just is a equation of integral PdX, no? That is work, no? Because force times distance is work, no? P times is the integral of dx is equals to work, no? Of one force only, but for a number of forces, finite number of forces, so it means the sum of all of that. So that's why there is a mission sign here. Okay. So U sub A is actually the external work done and can be expressed by this equation. Okay. So because we know that work is equal to force times distance. Okay, and there is force applied, and then the distance could be the displacement, not displacement, because once the force is applied to this arbitrary shape na body, the body will uh, kuan, be subject to internal strain, no? And then as an effect, it will also deform. Okay, so that is on the first diagram. Okay, we will continue. Okay. So I put equation. I'll just erase this. That's the equation one. Equation one. So equation one. Saglit lang. Okay. Ako problema. So the internal work also, no, the internal work is also a function of the external load. Thus, UI equals to UE is equals to function of P1, P2, Pn. No? So that is equation 1. I put equation 1 on the right side. Now, if any one of the external forces, say P sub G, is increased by a differential amount of dpg, internal work also increases. So strain energy would become U sub I plus dui, no? Or equals to ui plus uh, partial derivative of u to the I with respect to partial derivative of pg, no? So it's like that, multiplied by dpg, no? So this will be the equation, no? Now, further application of the loads caused by dpg to move to displacement delta g. So strain energy becomes ui plus dug or equals to ui plus dpg delta I. Okay. So you have now an equation of u sub I in here. So this is the internal strain in the increase the internal strain energy, no, expression of internal strain energy. Okay. So we will continue. Okay, we continue. Okay. So DUG actually will become dPg delta I, no, from this equation, because U and U sub I on the left side of the equation from equation 3, and the U sub I in the right side of the equation both cancel, leaving only DUG dPg delta times delta I. So this is it, no? Is the additional strain energy caused by dPg, the increase of the external load, dPg, no? So, dinhi atong gitry og increase by amount of delta Pg, and we see what will be the change of internal energy. So, this is it, no? So, in summary, equation this is not equation 2. Equation 1445 is equation 2. No? So I will change this with equation 2. No? I think I am going to to change this, no. Ako na lang siguro ni siya ikat ko na siya. Ikat ko na siya. So, asa ba to? So, ang may putabuan niya, ini siya, may siyang equation 2. Equation 2. Okay. And equation 3. This one will be equation 3. Okay, I think this one is workable. Dan ganyan, no? Actually, baka lagi ako ni ganyan, but I'll just erase the 14 because that's from the book. Okay. So in summary, equation 2, this one, represent the strain energy in the body determined by first applying the loads P1, P2 up to Pn. Then the increase of that external load. Equation 3, which is this one, represents the strain energy determined by first applying the PGN loads P1, P2, Pn. Since the stress, since these two equations are equal, require that delta I equals to partial of Ui over partial of Pg. So this is equation 4. I think this is now the Castigliano's theorem. Okay, so I will. Okay, so it says here that note that equation 4 is a statement regarding the body's compatibility requirement since it's related to displacement. So the derivation requires that only conservative forces be considered for analysis. Okay. So we go back. We have a body applied with a force. So we have we apply the conservation of work such as external work is equal to I think U is uh, strain, no? So you have the external work is equals to internal work, no? Internal work. So you have equation for the external work and for the internal work. And then din nila din i-apply ang mga derivation by increasing the amount of differential force, no? So there's also corresponding increase in the strain energy. So that involves derivatives, no? So that's why you see a lot of delta here, no? That means that we are applying derivatives. No? So until that from this somewhat long equation, we will have only a simple equation in terms of equation 4. So this one is more simpler to look rather than this equation. No? But if you notice the equation, so many will cancel. No? Okay, so we have equation 4. So it's a statement regarding the body's compatibility requirements. No? So we continue. Okay, this is known as this one is known as the Castigliano Theorem. So this is the Castigliano Castigliano's theorem. Castigliano's theorem. Okay, so the equation 4. Ano ba? Oh, ano talaga? Ha? Yan naman, yan naman. Hmm. Hmm. So, mawagi mo gamiton ka na? Oo, okay. Okay. Unsa nga kada ko ang kabigay dito pang 25? Ha? Okay na, okay. Mhm. Oh, kunya na lang mo anak ko mga after lunch. Ah. Katong kuan sa simbahan, ako nang tugad-tugapon. Si Arnold banda ko na dito. Oh, gipamunta na gyud kita na ako ang mga channel. So, actually kita na ako upat ka buok channel nga magtindog, upat sa channel nga horizontal. Hindi ko nga linding ba na maayos sa ID ma. So, nga o. Pero di ba ka to makasamok tanawon sa kuan mo abasa mo na to. Pagkasamok ka na ako sa mga, exercise ba? Okay, okay. So, mo ko siya mag-form og basket. Kay, criss-cross mo to siya, upat ka vertical, upat ka horizontal. So, dito mo sandig ang aluminum sa iya. Oh. Yang aluminum daan doon naman dito siya stiffness. So, ikaw sa to aluminum kay mo na kita na mga bangko siguro na. Oo. O sige, diyo, yan na lang, diyo, kanag-klase ko po. Ha? Saan sa bugat? Wala ko, nag-work na to. Work mo, ito man sa butan. Hindi ko to. Lagi-lagi po namin makita niyo sa internet bintag ko kita ay baka ng work. Nandito mo gamitin sa mga putahan sa mga armored car? Hmm. Sige, sige, sige. At may pabutahan na lagi. Hmm, 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 sige, sige. Hmm, hmm. Ah, okay, okay. O sige, klase pa ko yun. Okay, yan na lang. Okay, so this is the Castigliano's theorem, no? So we can apply this actually to the trust, no? Pero sa like for example, application niya, application, deflection of trust, no? Deflection of trust is deflection, deflection of trust. So one of the application of the Castellanos theorem are in terms of deflection, no? Deflection. So kung saan man na pag-apply sa deflection, so ako ipakita ang formula. Deflect, okay, deflection or deformation of gases. Rather, just say deformation, deformation. Okay, mas guwapo pa na pag ng deformation. Deformation of gases. Okay? So, ang formula din niya, Ana, is kung mangita ka ang deformation sa gases, is mo na ni we have UI uh, control. So, ang mahitabo karon ni ana, since the truss is subjected to an axial load, okay, just like this, no? Na siya mga load yung ana niya. Ang iyang internal energy sa truss mahimong axial, and that is equals to ui equals to n squared L over 2 E, no? Where A is the area, cross-sectional area, no? I will define here. P is cross-sectional area of truss, area of truss, of truss member. Now we assume that all members has the same area, so that's why only one A is used, and E is the strength of the material, no? Which is usually defined as the modulus of elasticity of truss member, whether it's made of wood or made of steel. So, depending on the type of material, no, it's also the value of the modulus of elasticity, no. So these are it, no. Ako nila ko on 16. Okay. And we have also in here, what is that in? I will see what is that in. Okay. Another term there is L, as the length of truss member, Okay. So, the length of truss member is L. E is the modulus of elasticity, and A is the area of the truss member. Okay. How about the term in? What is that in? Okay, I think that's the force, no? So, okay, rather, this is the formula. This is now the formula for thrust, no? Control. So, muna siya. So, di na ako mag-type. Ako na lang nailisan. So, from this equation 5, delta is the joint displacement of the thrust. P is the external force. So, we will have what we call, we will write equation 5, no? Here, equation 5 below. Definition will be in. Okay. Okay. So, actually, if we apply the one inside the parenthesis, which is the partial of a function with respect to P, the only thing that can be derived here is the N, no? Because L, the area and the elasticity are considered as constant, no? So they will not change. So only the force. So only the delta N dP, no? So what will happen is that so we can, okay. So There's another. Okay. So in order to determine the partial derivative delta in delta p, because as I have said, from this equation, the only variable that can be derived is n, not the L, not the A, not the E. No? So delta in delta p. So we need this. So N is the internal axial force in member caused by both force P and load on the truss. No? That's the N. Internal axial force. No? So meaning we have to determine before we do some like tawag na itong method of joints, no? Method of section, just to determine the internal force, no? Because N is the internal force. Okay. P is the external force. So in order that we can determine the partial derivative delta and delta P, we need to treat P as a variable, not numeric quantity. Thus, its internal axial force in must be expressed as a function of P. Okay. By comparison, equation 5 is similar to that used for method of vertical work, except that N is replaced by delta N delta P. Okay. These terms N and delta N delta P are the same since D represents the rate of change of internal axial force with respect to the load P. Okay. So we continue. Okay, so we have procedure for analysis. We have procedure for analysis. Okay, procedure for analysis. Procedure for analysis. This is it. Procedure for analysis. External force P. Place a force P on a truss at the joint where the desired displacement is to be determined. No? It's very important. Place a force P on the truss at the joint where the desired displacement is to be determined. This force is assumed to have a variable magnitude and should be directed along the line of action of the displacement. So not only that it is force on the where the joint where you want to determine the displacement, but also the direction of the force P is also the same direction as the desired the direction of the desired displacement that you are going to determine. Okay. How about for the internal force N? Determine the force N in its member caused by both real numerical load and the variable force P. So, duha ka mag-analyze, no? Determine the internal axial force in its member caused by both, number one, real loads, no? The real loads are the load that, the actual external load. And the variable load is the one that you place, no, on the joint. The displacement is to be determined. And what is the direction of the P? Is the same direction of the one you are going to determine. Okay. So there will be two types of load. Number one is the real load. So that load is the one acting on the trusses. Ang number one, ang ikadua is the P, which is actually maybe a determinant force, not P. Okay, just to determine the displacement. So yan na lang yung procedure. No? So I think we need to have an example. Okay, if we have an example here, okay, we still have to continue. Still have to continue. Control, have to continue. So we are still in procedure of analysis. Copy. Okay, we continue. So for the internal force, find the respective partial derivative delta in delta P for each member. After in and delta in delta P have been determined, assign P its numerical value if it has actually replaced the real force of the thrust. Otherwise, set P equal to 0. So this is known as the Castigliano Theorem. This one, Castigliano Theorem. No? So Castigliano Theorem. I don't know where is the first. Okay, we will come to that. No? Okay. So okay, so continue for the procedure of analysis. Wala pa tumuhuman. Copy. So, padayon pa, no? It is important to retain the algebraic sign for corresponding value of n and the partial derivative of n with respect to p when substituting this term into the equation. Okay, if the resultant sum delta n times delta n delta p li is positive, delta is in the same direction as p. If negative, the value result is opposite to p. So that is the meaning. Just like when we assume a positive sign in the method of joint, when we analyze for the internal forces of thrust member using method of joint, the first thing is when we do free body diagram of every joint, katong mga member nga wala pa nato ma-determine, we assume ta of arrow going away. No, meaning we assume them to be positive. Now, if the result is positive, then that force is positive. If we get a negative, then yeah, that's a negative, meaning compression. No? But the magnitude is okay. Magnitude will not change if the sign changes. Only that ang axial force man is directional. You have a tensile force, and you have also compressive force. Okay, so we can determine tensile and compressive force by its direction. Okay, because force is a vector. Okay, so actually taas-taas ni siya, but the most important here is only this one. No? The most important is equation 5 because equation 5 is known as the Castigliano secant theorem. No? Kini siya mo ni siya secant theorem. Okay. Kaya ako na siyang okay, mo na siya ang itawag na Castigliano secant theorem. No? We use this in determining the thrust. Pero pag determine mo sa thrust, paluhon mo ni siya nga procedure, no? Procedure. Okay? Procedure. This procedure is easier done than being said. No? Easier said than done, or easier done than said. Okay. So it's like that. So I think I need now for that example, just like this one. Example this one. Okay, example this one. So we have an example. Okay. Example. Ito nila ko. 16. Yeah, that. So, determine the horizontal displacement of joint C of the steel truss shown. Actually, kanyo tali kay ano, upat kami kami member. Upat kami kami member. Pero ang truss, nakita na ko nga all pin. No? All pin. Okay, all pin. Okay. Now, the height of the truss is 4 meters from A to B, and E to D is 3 meters. Okay, so A to C, that's 5 meters because this is a 3, 4, 5 triangle, no? So 3 horizontal, 4 vertical, the hypotenuse is 5 because the square root of 3 squared plus 6 plus 4 squared is equal to 25. So square root of 25 is 5. So this is a 3, 4, 5. Now, the area of each member is different, no? So you have a bigger area for EB and BC, while smaller area for BC and EC. So that means that the area of the trusses here are not the same, but they are made up of the same material. No? So you have a modulus of elasticity is equal to 2000, no, 210 gigapascal. No? This is already gigapascal, 210 because Newton per mm squared is megapascal. No? Newton per mm squared is megapascal. Newton per meter squared is pascal. Kilonewton per meter squared is kilopascal. But when we say Newton per mm squared, that is megapascal. Now, if we multiply this by 1,000, that will become kilonewton per mm squared. No? And kilonewton per mm squared is gigapascal. So that means that this is 210 gigapascal. Okay. So, to determine this actually, if you examine the formula, no, I will cut the formula here. I will cut the formula here. So, I'm going to consider this. Okay. Okay. So, muna siya ang problem. So, Castigliano's second theorem. O ni. Castigliano's second theorem. O ni atong giderive gani ha. Ato na i-apply. Okay. Okay. So, this is a mission, no? So, it depends kung pila ka buok member. Now, we have 1, 2, 3, 4. So, upat sad siya ka buok kakuan. So, we make a 4 rows, 4. Okay, so insert a row here. So, let us say 5. 1 for the title. 1, 2, 3, 4, 5. Then, stay like that, no? So, I put that. Ganyan ka na kung pilit. Tingnan na siya. So, first is you are going to determine the N, no? Because you need the L, you need the area, you need the E. I think we need the okay. I think this one is lacking. This equation is lacking, no? That the equation that I post is lacking. Inside the parentheses, supposedly delta N, delta P, no? So you still have to add another row uh, column, insert column to the right, and we need another column, insert to the right. So first is you need the in. Next is you need the I'll just say DNDP. Okay, and we have the sum, no? That you have the in multiplied by DNDP multiplied by L divided by the product E. Where you get in the first column, second column, third column, fourth column, you perform this, no? You perform this. Like for example, N times D in DP. So it's just a product of these two. Then if you include L, you multiply by L, you divide by this one. So I will add another here. I will add another here as the identification of the member. So insert columns to the left. So we just see member. There. Okay. The first member is we say EB, no? EB. Next is BC. All the member, I have said po kabuk niya ka member. BC. You have also AC. AC. I think, so wala. EB, BC, EC. CD. CD. What tayo CD? Okay. CD. Hindi, madugang mo kita isa kay saman. So, natay submission. So, insert taog 1. Insert taog rows below. And this is for the big S. You see submission. Submission. That means that if we are going to sum all of this value, no? If we sum all of this value, like that. If we sum all of that, okay, we are already performing this one, no? But this one is wrong actually. I will change this equation, no? I will change this equation. So how will I change that? Yeah, I'll just insert equation. It's easier to type. Equation. I think we are almost time, no? So, ano na lang, no? Yani, mo-end ako in a minute. Okay. I'll just type the equation. So first you have the delta, okay, is equal to summation. Then you have the n, then the product of d and dt. Then you have the product. This one, L and R. Okay. So I will just copy and then paste that here. Paste that. Okay, this also because it lacks. Okay, so this is the equation actually, no? So since we do not have time, we cannot fill all the cells here now. BBL, yeah, because it's there now. So like AB that's 4 meters, and BC is 3 meters, and EC is 5 meters, and this one is 4 meters. So I'll just fill up the first, what I did here is I just fill up the first, second column. Okay. So that's it, no? So area, elasticity, like that. Elasticity also is 210 gigapascal. You can fill that the same all over. So that's it, class. No, I will save this and I will uh, upload this later, and I have to stop because it's already time. So let me see the what we've done today.